Bismillahirrahmanirrahim. Our next theorem, that let T1 be a linear transformation from the vector space U to the vector space V over the same field F. T2 be a linear transformation from the vector space V to the vector space W over the same field F. And alpha is any scalar, and alpha is a non-zero scalar. Then prove that alpha multiplied by the composition of T2 and T1 is equal to the composition of alpha T2 and T1 is also equal to the composition of T2 and alpha T1. Since T1 is a linear transformation from the vector space U to the vector space V, therefore the image of X under the linear transformation T1 is an element of the vector space V, for X is an element of the vector space U, and T2 is a linear transformation from the vector space V to the vector space W. Therefore the image of T1X under the linear transformation T2 is an element of the vector space W. Also, the composition, that is the T2 T1X is the composition of T2 and T1 is a linear transformation from the vector space U to the vector space W. Also, by another theorem, the alpha is any scalar, then the composition of T2 T1 multiplied by the scalar alpha is a linear transformation from the vector space U to the vector space W. And alpha T2 is a linear transformation from the vector space V to the vector space W. Therefore alpha T2 is also a linear transformation from the vector space V to the vector space W. T1 is a linear transformation from the vector space U to the vector space V. Therefore, alpha T1 is also a linear transformation from the vector space V to the vector space U to the vector space V. And the composition of alpha T1 is also a linear transformation from the vector space U to the vector space W. And the composition of T2 alpha T1, where alpha T1 is a linear transformation from the vector space U to the vector space V. T2 is a linear transformation from the vector space V to the vector space W. Therefore the image of alpha T1 under the linear transformation T2 is an element of W, for an element X is contained in the vector space U. Therefore the T2 composition to alpha T1 is a linear transformation from the vector space U to the vector space W. Let alpha T2 composition to T1X is equal to alpha T2 T1X, where T1 is a linear transformation from the vector space U to the vector space V. X is an element of the vector space U. Therefore the composition of T2 T1A, which is equal to composition of T2 and T1X. That is T1 is a linear transformation from U to V, and X is an element of U. Therefore T1X is an element of V, and T2 is a linear transformation from V to W. Therefore we can apply the linear operator T2 on T1X, which is an element of V, which is also equal to alpha T2 composition to T1X, which is also equal to alpha T2 composition to T1 on X. Also T2 alpha T2 composition to alpha T1X is equal to T2 composition to alpha T1X, where X is an element of the vector space U. T1 is a linear transformation from U to V. We can apply T1 on X. The result T1X is an element of V, and we can multiply a scalar with the element of V, which is again an element of the vector space V. That is alpha T1X is also an element of the vector space V, and T2 is a linear transformation from V to W. Therefore we can apply T2 on the result of alpha T1X, which is equal to alpha T2 composition to T1X, which is also equal to alpha T2 composition to T1X. That is the alpha multiplied by composition to T2 T1 is equal to alpha T2 T1X, and which is also equal to this result is also equal to T2 composition to alpha T1. That is this result is equal to this result is equal to alpha T2 T1, and this result is also equal to T2 alpha T1, which is our required target.